In this video, you will learn how to find the equation of the ellipse in standard form with center at the origin and given the coordinates of the vertices and the foci. Example 1. What is the standard form of the equation of the ellipse that has vertices with coordinates positive, negative, 6, 0 and foci with coordinates positive, negative, 5, 0? To find the equation of the ellipse, let us plot the points in the Cartesian plane to visualize its orientation. Let us locate the given points. The vertices with coordinates positive 6, 0 and negative 6, 0, and the foci with coordinates positive 5, 0 and negative 5, 0. This means that the center is located at the origin with coordinates 0, 0. From the points, we can say that it is a horizontal ellipse with center at the origin. Hence, we will be using the equation x squared over a squared plus y squared over b squared equals 1. From the Cartesian plane, the distance of the vertices from the center is 6 units. Hence, the value of a is equal to 6. The distance from the foci to the center is 5 units. Therefore, the value of c is equal to 5. To solve for b, we use the relation b squared equals a squared minus c squared. b therefore is equal to the square root of a squared minus c squared. Substituting the values of a and c, we obtain b equals the square root of 6 squared minus 5 squared, which can be simplified as the square root of 36 minus 25. Simplifying further, this will obtain b equals the square root of 11. Plotting the co-vertices in the Cartesian plane, we have the following points, with coordinates 0 and positive square root of 11, and 0 and negative square root of 11, and the graph of our ellipse looked like this. To determine the equation of the ellipse shown in the left, we substitute the values of a and b in the equation x squared over a squared plus y squared over b squared equals 1. Since our value of a is equal to 6 and the value of b is equal to square root of 11, then we will have x squared over 6 squared plus y squared over square root of 11 squared equals 1. And simplifying this one, we will have x squared over 36 plus y squared over 11 equals 1. This is now the equation of our ellipse. For our second example, find the equation of the ellipse in standard form that has vertices at 0, negative 5 and 0, positive 5, and foci at 0, negative 4 and 0, positive 4. Following the same procedure in example 1, we plot the given points in the Cartesian plane, starting from our vertices with coordinates 0, negative 5 and 0, positive 5, and foci with coordinates 0, negative 4 and 0, positive 4. From these points, we can tell that this is a vertical ellipse with center at 0, 0, and we will be using the equation x squared over b squared plus y squared over a squared equals 1. Since the distance of the vertices from the center is 5 units, therefore the value of a is equal to positive 5. And since the distance of the foci to the center is 4 units, therefore the value of c is equal to 4. To solve for b, we will use the same relation, which is the b squared equals a squared minus c squared. And by substituting the value of a and c, we will have b is equal to the square root of 5 squared minus 4 squared, which will give us square root of 25 minus 16, which is equal to square root of 9, and therefore the value of b is equal to 3. Plotting then our co-vertices, we will obtain this graph. Substituting the values of a and b in our equation, we will have x squared over b squared plus y squared over a squared equals 1, and using the values of a, which is 5, and b, which is positive 3, we will have x squared over 3 squared plus y squared over 5 squared equals 1. And we simplify this, we will have x squared over 9 plus y squared over 25 equals 1. This is now the equation of our ellipse in standard form with vertices at 0, -5 and 0, +5, and foci at 0, -4 and 0, +4. And now it is your turn. Please pause the video and try answering the following.